Hello everyone. In this video I'm going to be reviewing finding the domain of a radical expression. In this case, I have my expression here, 4 times the square root of 2x minus 7 plus 10. When I look for the domain of a radical, simply put, I want to focus only on the radicand. In other words, what's inside the radical. In this case, that's 2x minus 7. So I'm only going to focus on that. I'm not going to worry about the 4 or the 10 outside the radical. My only concern right now is the 2x minus 7. Since for an even root, whether it be square root, fourth root, what have you, since for an even root I can't have negatives inside the radical, I want to find out when will this expression, 2x minus 7, be positive or be 0. The only two things it can be besides negative. So to set that up, I'm going to use the expression, or set up the inequality, 2x minus 7 is greater than or equal to 0. This is the algebraic way of saying 2x minus 7, that expression cannot be negative. So now I'll solve by solving the expression as I normally would. In other words, I will add 7 to both sides. Now I have 2x is greater than or equal to 7. And then I'll divide by 2. And I'm left with x is greater than or equal to 7/2. Now keep in mind, when we have an inequality, if we ever at any point multiply or divide by a negative number, we flip our inequality. In this case, I divided by a positive 2, so it wasn't necessary. So I have my domain of x is greater than or equal to 7/2. And if I want to be more formal about it, I'll identify x as my variable, and I'll say x such that x is greater than or equal to 7/2. And that will be my final answer for the domain. With domain of radicals, this is the basic way we approach it. One of the particular examples we have to be careful of is a situation like this, where we have a single radical in the denominator. And again, I emphasize the only thing in the denominator is the radical. So in other words, there's nothing being added to the radical outside of the radicand. There's not, for example, a 3 plus in front of it. The only thing that is there is the radical itself. When that's the case, the inequality that we set up, we're still going to focus only on the x plus 1, but instead of saying greater than or equal to, we're just going to say greater than 0. And the reason is, we don't want our denominator to equal 0, so we have to eliminate that possibility. So again, we can't say x plus 1 is greater than or equal to 0, because we don't want the denominator to equal 0. So instead, we say just greater than 0. We'll solve it the same way. I'll subtract 1. So now I have x is greater than negative 1, and I have my domain.